The talk is called Lector in Código, which the title already a bit weird. Is a play on words from a book by Umberto Eco called Lector in Fabula, which is already a joke about how literary theorists see the reader inside stories. And this one is called Lector in Código, and in half Latin, half Spanish, because yeah, it's another joke that we have with a Roman friend where we try to speak in whatever the latest Roman Empire language used to be. So thank you, Julius Caesar, for giving us Spanish, Italian, Catalan, Portuguese, French, and you name it. Anyway, I work at Microsoft. I'm really happy that this year we are diversity and inclusion sponsor for the event. So thanks to them. I don't want to say us because it doesn't sound nice. And before I start, I want to explain the story of why one of our rooms is called Clementina. Clementina was a computer, or the first computer that arrived in Argentina. It came from the UK. I think this person here, maybe Veronica can correct me, is Cecilia Verdicheschi. Yeah, so Cecilia Verdicheschi was the first programmer from Argentina. And yeah, they actually learned from a colleague from Alan Turing. So the lineage in Argentina is Turing, this Cecil Poppenwell, and then Verdicheschi. And for us Uruguayans, this is also very important because back in the 60s, when the Uruguayans were also trying to do programming, they will code everything in their minds, and once a week they managed to take a ferry, an overnight ferry to Argentina, where they run their code. So let's talk about programming, right? Yeah. So this is Ida Holtz, one of the first engineers from Uruguay. As you can see, women were the pioneers everywhere. And during the dictatorship, the dictators will take them out of jail, bring them to the computers, and make them read code, because for sure, all these leftist people will have hidden messages in those programs. So that's what happened during those dark years of Latin America. Anyway, back to the talk. So the idea of the talk is to explore the relation between the process of writing computer programs with that of writing literary works of fiction, and try to see why is there or if there is a relation there. And there is a lot of influences that I took from Umberto Eco, who was an Italian writer. More than Italian, he was from Torino, and more than from Torino, he was from Alessandria. So he was an Alessandrino writer. And yeah, the thing, or one, yesterday they were talking about axioms, things that we assume to be correct. A kind of axiom that I want to have is that when we read programs, we are using the kind of the same brain or capabilities, let's say, that we use when we interpret text, when we interpret fiction. Actually, there is some research trying to map brain areas when we solve programs, and the linguistic areas of the brain are very active when we read code. So, yeah, I think if literary theorists have all these many years of research trying to understand how a book works, what devices are there that make it understandable, and so on, why don't we use that also for trying to understand programs? And final disclaimer, I finished the talk 15 minutes ago, so be careful. So the book I mentioned from Eco is Lector in Fabula. I don't think you can find this book in English, probably Spanish and Italian for sure, but I'm not sure if you can find it in English. And then he has another one called 6 Walks in the Fictional Woods. These are his Norton lectures at Harvard. That one is super interesting also on how we read, basically. And the idea is that what can we learn from these theories to become better programmers, for some definition of better, whatever that could mean, right? I want to start with a paper that is from the 60s, I think, and it's the best unknown paper because back there, this person already was talking about how programs should be readable, that a programmer should write for other programmers, and the value of a program is how long it lives over time that you can still understand it. That was this person was saying as was the main features of a program. And we don't know who wrote it because this was somebody had the luxury of being tasked with scanning all the collection of papers from Donald Knuth. Imagine to have access of Donald Knuth archives. And they found this paper, and not even Knuth knows who wrote that paper. So if Knuth doesn't know something, then probably nobody else does it in programming. So maybe somebody that can get that Datamation magazine knows, but yeah, it's not attributed there. Anyway, this paper says at some point, a programmer does not primarily write code, rather he, you can see the time, it was a he, the programmer, even though the picture evidence showed that it was she, he primarily writes to another programmer about his problem solution. Another thing, if you think that we program just for machines, then you are at the wrong talk. The idea here is that we program to communicate solutions to other programmers, and those solutions are executed in a fast fashion by a computer. And you know that one? Don't edit your slide 5 minutes before, then you get with a capital S somewhere. Programs must be written for people to read and only incidentally for machines to execute. This is from the book SICP, Structure and Interpretation of Computer Programs from MIT. Also, what I'm trying to say is like this idea of programs being written for humans is not new. It is basically since the beginning of programming. And a final paper that I want to show about that is when David Wheeler, the one from the Burroughs-Wheeler transform, introduced subroutines back in the early 50s. He brought that, I mean, he's explaining why we have subroutines, how they work and whatnot. And he says, like, the above remarks might be summarized by saying that subroutines are very useful, although not absolutely necessary, and that the prime objectives to be borne in mind when constructing them are simplicity of use, correctness of code, and accuracy of description. All complexities should, if possible, be buried out of sight. He was saying this, I think, in 1955 or 53, I don't remember. Point being, yeah, we don't need subroutines. We don't need any abstraction. We just could write plain, not even assembler. But that's not the point. The point is that we humans need to understand what the code is doing, be able to read it later, debug it, share it with colleagues, and so on. So let's talk about Node.js, right? That's why we're here. Don't change your slides before doing the things. That is what I wanted to show you. We have that code, right? Why don't we just have that code? It will work anyway. And 2 slides before, in that book, you know, probably there is a book that this is the title. It's a really interesting book discussing it's discussing this one line of code during a whole book, basically, and trying to see what is important there. And they say the presence of those optional spaces indicates some concern for the people who will deal with this code rather than merely the machine that will process it. So there is no need to have a space after the semicolon, I think. I did BASIC many years ago. So yeah, the point here is like when you write it in this way, you are assuming there is a human that will read it because there is actually no point in doing that. You can just write like that. Yeah, enough Node.js. Literature and programming. To have a relationship or to find a relationship between literature and programming, this is not new. You know already or have heard maybe about literary programming by Knuth. And he says in that paper, instead of imagining that our main task is to instruct a computer what to do, let us concentrate rather on explaining to human beings what we want a computer to do. Same idea all over the place. But the problem with the paper from how I see it today is that, yeah, introduces the web system. So that's how Knut called his literary programming system. The idea is that you will write documentation along with the code. Actually, in a literary program, you are always writing documentation, and then you need kind of comment out the code, and then the program will know when to execute code or just or what are comments. But actually, the main thing in the text file is the comment. The one with the special characters surrounded it is the code. And we can see that today, maybe tools like JavaDocs or whatever, they can embrace some of these ideas. But the paper explains how web works, but it does not say anything about how to write code that is easier to understand. It's very philosophical, and yeah, but doesn't say, take a look at this, take a look at that. Then there is somebody from Denmark, if I'm not mistaken, that he wrote a book called Cybertext, Perspective on Ergodic Literature. By ergodic, he means is literature that requires an effort from the reader to be understood. It's not something that you just read it out like any summer novel, let's say. Like the work from the American, I think it's called Danielewski, House of Leaves, or reading Borges, or maybe also Eco, or the, I think it's called I Ching, the divination thing from fortune, I don't know, from China, where the whole text requires that you jump back and forth and go, make a proper effort to understand what's going on. And he also talks about code, because reading code requires you to do all these adventures in different paths to get back and say, yeah, this actual piece of code is doing this or that. And there, because Knut talks about having code with some kind of literary value, like you could say Cien Años de Soledad has for literature, or Joyce or Shakespeare or whoever. But actually, he says, a search for literary value in texts that are neither intended nor structured as literature will only obscure the unique aspects of those texts and transform a formal investigation into an apologetic crusade, which I think is true. I don't think we should be looking for literary value in code. I mean, at least in industry code. If you want to do poems with code and do some kind of art with code, that's fine. But I'm talking mostly about code that we do in the industry that we have to share with colleagues, or it's maybe open source, or part of some research problem to prove an algorithm, let's say. So I agree with this, that I don't think we should be looking for that kind of literary value. And I think it also puts people away from the main ideas, because you can think, yeah, these artsy people are already with whatever they were drinking this morning, and yeah. So, and also he says that programs, again, are normally written with two kinds of receivers in mind, the machines and other programmers. This gives rise to a double standard of aesthetics, often in conflict, efficiency and clarity. And yeah, this is also a problem, because when you want to write like clean code, you always have this idea that we should do it as performant, if that is a word, as possible. When, on one hand, I think, I don't remember his name, but he's been a speaker at this conference. He talks a lot about performance. If you write clean code, actually, the compiler can easily inline the code and optimize the code. So in a way, writing clean code helps the compiler. But anyway, sometimes we have this tension between these two extremes. I want the program to be efficient, because at the end of the day, I have a hardware that is running the code. And on the other hand, I want programmers to be able to understand what this is saying. But then Feline, which also has spoken here, she has a paper that says that a difference between writing and programming is that in programming, the programmer gets feedback very early, on whether the program text is executable during compiling. Furthermore, they get feedback on whether the program is working as intended. Yeah, this is a big difference with literature, because when you're writing a book, you have no idea if somebody will understand what you're writing. But in a program, at least if it produces a correct result, then it's kind of fine. But on a way, I don't agree with this, because, and we will see why later, the feedback we get has nothing to do on how we wrote the code or what the code is actually implementing. And we will see with examples. A good thing from this is that in literature, you rarely find books that are written by many people, because it's really hard to combine all these ideas. There are some collectives, like in Italy, there is a Wu Ming collective. There is 5 people writing those books. I think they kick out one of the Wu Ming people. Because in here, think about open source collaboration. Whenever we write code in open source, at least we know that it has to do something after it's executed. So we kind of can do this super collaborative writing. But in literature, it becomes super hard. But back to the point, what I am interested in is not in what the code produces, which is important for sure, because code most of the time is utilitarian. We do it because it will do something for us. But for me, it's more important what the program means, what process of the real world is trying to represent, or how the problem was solved. So we can compare this with music interpretation. These are, I don't know who plays guitar here, but basically these are the notes on a guitar. You have the 6th string and the first one, because when you write the guitar, you reverse it for some reason. That's how usually they are represented. So anyway, that's the top string, the lowest string, and these are the notes there. What's the point here? If you look, this note is exactly the same as this one as this one, this one as that one, because that's how basically you tune a guitar. You go to the 5th fret, and then you compare to the next string and whatnot. What's the point is, like, you can play that. This is from Abel Carlevaro, an Uruguayan music teacher and guitar player and so on, that he developed a method of guitar playing, and the notes, you could play them wherever you want. But he says that there is no correct guitar playing if you know the fingering, like where you place the fingers in the guitar. That's why you have all these numbers here. He's telling you in what string and what finger should actually press the note. So my point is, you can have the same results, the same music, but for a correct interpretation of that and so on, and the art of guitar playing, it really matters a lot which fingers you are using in both hands, and what position on the neck you are using, and so on. So if we go back to this early feedback that we can get from programs, Nut, for example, he said that is 2 a random number? You have a random function implementation that returns 2. That's completely random. I mean, I chose 2, 5, 17, I don't care. Like, think of any number. That's like a random in a way. Or we have a square function that returns a hard-coded 25. That is a correct implementation. As long as you provide 5 or minus 5 as input, it's still correct that you return 25. And in a way, TDD advocates this kind of program building, which for me is kind of, because I get results, but my most important thing is what is written inside the function. And like Alan Kay says that Dijkstra is the unit on how you measure sarcasm in computer science. I think they are called milli-Dijkstra, something like that. Anyway, the milli-Dijkstra person says that program testing can be used to show the presence of bug, but never to show their absence. So again, all this early feedback thing, I'm not sure. Today we have quick check. Quick check kind of tries to alleviate that somebody didn't just hard-coded 25 somewhere. But yeah. So my question is, how can we share knowledge between programmers? How many of you have heard this from your colleagues? The code speaks for itself, or you said, one person, only one person, 2, 3, 5. Okay. I mean, I used to work in a team that everything was in Erlang, so imagine that reading that code was super easy, very simple. And all the code spoke for itself. But we need to understand that we are not adversaries in a security sense, even if you will. So imagine that every time we try to read a book, we had to play code breakers. Imagine if that was how literature was written. Unless, for sure, we are reading Finnegan's Wake. If you go to Joyce, that's a different take. But that's, in general, the author tries to be accessible. So how to share code, knowledge, sorry. There is this paper by Peter Naur, which is called Programming as Theory Building. And he talks about that whenever we code, we have this theory about how the whole system is implemented. And the person that knows the theory and has built the theory about any program and process, they can provide explanations, justification, answer queries about what is the program actually doing. Like I used to work at RabbitMQ. Maybe that RabbitMQ was the Erlang code base I was mentioning before. I don't know. So at RabbitMQ, for those that don't know it, RabbitMQ implements the AMQP protocol. As you implement a protocol, you need to follow the rules of the protocol. But RabbitMQ didn't implement the immediate message flag, which kind of tells you if a consumer received the message or something like that. Why? Because it was really hard performance-wise in a distributed system to be able to tell a publisher that is sending 20,000 messages per second that on the other end of the network and on the other end of the cluster, somebody took the message or something like that. So we, RabbitMQ programmers, have a theory built around that, why this is not there, and we can explain it. Or why in some page of your code on some file you have duplicated code. Like for somebody fall into the code, they come there and they say, but why this thing is the same as somewhere else? I used to work in a company where we call it the if France, because the code worked the same everywhere except for France, because for France there were special rules and the s'il vous plaît and whatever. Anyway, so yeah, as programmers, we can build this theory, but Naur says that this theory is very hard to share, and it won't. He says at least that it won't be reflected in documentation or the program text. And they have run experiments like bringing new people to teams and see how they integrate and whatnot. And it's really hard actually to have somebody come in and know all the history of why RabbitMQ decided to implement queues in a way that re-implement the operating system, hard drive caching, let's say. But when we got SSD drives very commonplace everywhere, we could take out all this implementation. Like today in RabbitMQ, they are called lazy queues, because lazy queues use the new drives. But somebody that is completely new to RabbitMQ and see that, why do you have 2 queue implementations? This one seems to keep everything in memory and does its own flashing. This one doesn't. So we, all team members, knew all that thing. But it's really hard to share and reflect it. So how can we share this theory? Umberto Eco talks about the encyclopedia, and there is 2 encyclopedias in his theories. One is the uppercase one, which states that this is all the knowledge that exists in the world, and the lowercase encyclopedia is my knowledge of the world. So it's world's knowledge versus my knowledge. Sorry if I go back and forth because I couldn't get the no mirroring setup. So I don't know what is the next slide. Yeah, and as a South American, always improvise on stage, never rehearse. Anyway, something that Umberto Eco says that is like a criticism he does of information theory, like I think in Lector in Fabula or the semiotic book, you can find that Umberto Eco explained all his theories based on information theory with all the math formulas and whatnot. You always wonder what Eco didn't know about, because whatever you talk about, he wrote about it. He wrote about programming languages, for example. So there is a lot of, if you start digging on his archives. But he says that a problem that information theory doesn't consider is that the competence of the destinatary is not necessarily that of the sender. Yeah, we know how to encode messages, how to send them around and whatever, but does the other person or the other end knows how to decode that thing? And that's the problem with the encyclopedia that we have to share whenever we are trying to share knowledge. Why? Because whenever there is absence of details in a work of fiction, or mostly any time, we fill in those details from our own encyclopedia. So if you were reading Tolkien, and when Frodo gets stabbed, you actually hurt Frodo, because Tolkien never explained that Frodo has the same physiology as humans. So we made him bleed, we felt his pain, blah, 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 because those details are not there. If you want a less dramatic one, if I say I took my carriage and went back to the hotel, we probably put there a horse pulling that carriage, even though I never said there was a horse pulling the carriage, and there was a street on which the carriage ran on. And that's how the writer is building the reader with those details, and then maybe the reader comes here, and the author says, and then the carriage levitated away. This rewrote all of understanding of what we just read, confirmed that our encyclopedia wasn't exactly matching with that of the author, and now we have a flying carriage going back to the hotel. So there's always this play between the author and the reader, and what we do filling in details. So think about it. When we have a class which has some name like user or order from a supermarket, and we try to fill in details about that order. How much are we really matching the business that is actually happening behind that code? Like, think as a tiny detail. You have a supermarket selling water, and we programmers say, yeah, they sell 6 packs of water, and that's in our system. And then tomorrow, a customer goes to the supermarket, tries open the 6-pack, takes 1 bottle, goes to the cashier, and pays for the bottle. What happens to our inventory that was supposed to be reflecting that reality? That when the owner of the supermarket explained the business logic and told us that they sell 6-packs or products, we filled in details from our own encyclopedia, from our own experience of supermarket shopping, and made an abstraction that actually doesn't reflect what happens in the actual supermarket. And it's something very simple. Just go there when we fill in details about gender, and we ask people about their gender when we actually don't have to do that most of the time. Why are we filling details that things maybe are there, maybe are not there, and how can we make the code do that? So yeah, I already said that. This happened when you don't see your next slide. And Eco says that basically most work of fiction, they are parasitical works. These parasites, they live from the real world. And all these details that we leave out are filled in. In the same way, when Eco talks about programming languages, he says they are parasites of English. Because all the meaning in most programming languages, those English-based, let's say, take actually the meaning from English. So there is no actual thing that signifies anything in a program. So he says, like, fictional words are parasitical words because if alternative properties are not spelled out, we take for granted the properties holding in the real world. So that happens all the time. Again, the exercise is bring this to programming. That's the idea, and see how well our abstractions, our code represent these things. Another idea from Eco is that of the model reader. The model reader is basically a mental image that the author has about who is their, in a way, target audience. So there they need to choose what language they write the book in, what kind of level in that language they use. Is it an academic type of writing? Is it a more summer novel type of writing? And besides that, the author builds the model reader as the book progresses. So Once Upon a Time already sets you up for a fabula, I don't know if it's like a children's story, because you expect that this Once Upon a Time, this probably didn't happen. But if you start reading Borges, and Borges starts like, I was walking through Buenos Aires, doing this and doing that and doing that, you're always questioning yourself, is this actually Borges? Or is an author, a character inside a Borges story called Borges? That is really hard, because the way Borges builds the model reader is he expects a reader that is able to play with his own story, and that you are able to see that he's actually playing a joke on us. So we have the model reader. We need to keep that in mind when we write code. Like, again, we write a function. I remember when functional programming started to become more popular, everybody was writing false and everything in their code. Are your colleagues there yet? Are you trying to show off, sorry? I mean, I don't know. Maybe it's just a fold, and it's really nice, and it looks really pretty, but what are we accomplishing with this kind of code? So model reader, not the empirical reader. That's very important. The model reader is never any person we know. Even if we think about some of them, it's just an idea, let's say. Lives in the mind of the author, the empirical author, because we will see something soon. And the author also, as they write the story, they're building this model reader, and it helps the author decide how much detail to include in the story. So again, I don't know the next slide, but there is also the model author, which the reader builds and tries to decode what this person was trying to write, which is not the empirical one. And something really cool from literary theory is to understand that the first character we ever meet in a book is this fictional storyteller that starts telling stuff. That's not the author. That's a character from the book that tells the story. And it's a very nice line there, which is very well explained in the story Borges y Yo, so Borges and I, or something like that, or Borges and me, where Borges plays with how this fictional Borges is taking over his life as he evolves. I just have 5 minutes plus the 5. We started late, right? So textual cooperation. You look at this thing. We see that on the metro, on the tube somewhere, and it says dogs must be carried on an escalator. This is from a literary theory book. Does it mean that you must carry a dog in the escalator? Are you going to be banned from the escalator unless you find a stray dog to carry? Carry is to be taken metaphorically and help dogs get through life. How do I know this is not a decoration? Must be now? Is the escalator this one here, some escalator in Paraguay? I don't know. So point is, a text, as Eco says, is a lazy or economic mechanism that lives on the surplus value of meaning introduced by the recipient. Basically, a text wants someone to help it work. And we have this cooperation game. So in that thing, we, after seeing so many signs and reading so many things, we know how that thing works. If it's placed here, you know it's decoration. But if it's placed on the tube, you know there's an authority that will get you and enforce that. So reading, even if we think it's something very simple, has all these very complex things going on behind in our minds. And yeah, we as readers are playing this strategic game as between authors and reader and saying, did they mean this thing? Did they mean that other thing? And Eco says that the better model we build of the author or of the reader is kind of this battle between Napoleon and Wellington when, according to Eco, Wellington managed to build a better model of Napoleon and beat him at this strategy. And Bourdieu, he talks about textual devices. When we understand that sign or any text, we have at least 500 years of literacy, at least in the, let's say, Western world, from some definition of Western world, where we are taught like books have paragraph, have italics, have bold characters, like a lot of devices inside the text that help us understand the text. So what are these devices that help programmers? Why, when we read code, a discipline that is like 60 years old, or even less because high-level languages weren't a thing back then. For example, we can have type declarations. We can have documentation that are all these devices that help us read code. And a really cool one, which comes from literary theory, is paratext. So what are these paratexts? So a paratext is a series of messages that come together with a book, like the jacket copy, titles, subtitles, and so on. And Genet, the French guy that came up with this idea, says that imagine that you have to read Ulysses from Joyce, and you don't know it's called Ulysses. How do you interpret that book? So that is how important a paratext is. So in code, as I say, we have documentation, package name, folder structures, like pragmas in Haskell, imports in other things, compiler flags. Like, how do you interpret a file of code if it's running in test mode where many things are being mocked? The meaning of that text changed completely because the paratext is different. A problem we have is that how we keep paratext relevant. How do we keep comments up to date? Like if you look at Don Quixote from Cervantes, the original description of chapter 10 doesn't match the content because the editor tried to split the book and he forgot to change all these paratext below the subtitle or the title, and then it has nothing to do chapter 10 description with chapter 10 content. So keeping comments up to date is a problem that is probably 600 years old or more. Consider this code to see what the paratext is. We have a class user, we have a username, password, and role. We have getters, the works. What is this class doing? We have no idea. It's really hard to understand the meaning of this class. But if we can have tests that it works, early feedback. But if I have a paratext, I know this is authentication on a database. If I have this other paratext, maybe it's a model that a user that log into my website. Just an example. So just doing that change the whole meaning of the text. Or if we go to Belgium, we have that this is not a person, and you have the person there, right? So how do you interpret that text? You probably saw that this is not a pipe thing. If I have to explain my jokes, it's because they're really bad. Anyway, how to build a model reader for a code. We have metaphors. I already gave a talk here like 2-3 years ago about metaphors we compute by, based on Lakoff. And for example, if you are choosing the right data structure, you can help your colleagues understand the intent of the code. Because you can keep a bunch of users, let's say, on your website into an array. Works. I mean, you can put records on an array. It will work. But if you put them on a set, you are telling your reader that the users in that website have to be unique, because that's a property of sets. So just by using the right data structure, we are already incrementing the understandability of our code. If we use a linked list, we are telling we need these properties on accessing the speed on the data structure. If we have a queue, we are telling them we have first in, first out. The stack tells something completely different, even if all the records inside are users. So tiny details that help understand code. And yeah, the explanatory power of a program is the measure of its elegance. Like, we can just write pointers all over the place, right? And data structure, yeah, have explanatory power. And when we use metaphors, we can do cognitive leaps. Like in distributed systems, back in the 80s, Xerox was doing an algorithm for replication, and they tried to do rumor mongering. Basically, a node has to share data with 2 neighbors, and then this neighbor share data with 2 other neighbors, and so on, and that's how they were doing replication. Really cool, really hard to work mathematically. But they came with the idea of epidemics. Do data replication in the same way an epidemic work. And then they had a whole cognitive leap. There was mathematics done to prevent epidemics spread, and they had all the math to work with their algorithm, just because they found the right metaphor. I'm finishing, so don't worry. I won't keep you here all day. So clean code. What is clean code? I think that clean code, in a way, doesn't exist. Because clean code is clean for some set of people, for a set of problems in a particular company or a particular open source project. So hola or ciao from Antonio Gramsci, you know the guy. I want to put this in a sort of joke, but to make us reflect. He says, like, hegemonic culture propagates its own values and norms so that they become the common sense values of all and thus maintain the status quo. Imagine when we have new people in a team, people coming from different languages. Are they going to be able to conform to these norms? Are these norms going to adapt or not? I don't know. I mean, it's really hard to say that if you follow these rules or do this literary theory or follow these design patterns, you will end up with clean code. No. And yeah, you can ask me if I'm a communist. If you are mad because I cited Gramsci, I will ask you if you're against Belka and Strelka, the first dog in space, right? So don't go against communism. Anyway, clean code. To get clean code, you need a shared encyclopedia. You need shared reading competences. And by definition, it's old, because as soon as the problem changes, there is a merger in a company. And the other supermarket uses different things. Is that clean code and all these norms already relevant? Maybe not anymore. And finally, Eco says that there are modes of interpretation, but basically semantic interpretation is a result of the process by which the reader, facing a linear text manifestation, fills it up with a given meaning. So we are reading code, we are trying to see what the code means. But critical interpretation is, on the contrary, a metalinguistic activity which aims at describing and explaining for which formal reason a given text produces a given response. So let's get critical. When we start reading code, try to understand not only what the code is doing, but how and why we got to understand the code, maybe because of the formatting, because of the design patterns that were used. I don't know, but let's try to think about that. Thank you. Papers. So, thanks.